Alright, now solving both polynomial and rational inequalities. Right, inequalities. So we're going to use the similar strategy to what we did in chapter 3 with quadratics. Right, so quadratics really are polynomials, they're just 2-degree polynomials. So we're going to do the same thing. We're going to find the boundaries, which are the zeros, and then between the boundaries, between the zeros, you should either be positive above the x-axis or negative below the x-axis. And you can do it by graphically or setting up a table. And so this is sort of an example of a polynomial case where we'll find our boundaries, which are our x-intercepts. We'll find it when it's positive, bigger than 0, find it where it's negative. And so this is sort of the concept polynomials. It's the exact same concept that we use in chapter 3 with quadratics. It's just going to be a little more complex with polynomials and rationals. But the same idea. The first thing we do is we find the zeros. That's the very first thing we do. Right? These are my zeros, which are my boundaries. Right? My function equals 0 in this particular graph at -2, 1. It's got symmetry. Right? So -2, -1, +1, +2. And so that's where the function equals 0. Between the boundaries are where it's either positive or negative. And so we did both cases here. This is the case where it's positive. Alright, it's positive when it's above the x-axis. Right, and so in this case, it's above the x-axis on this part. Well, it's between the 2 and the -1. -2 and the -1 and the +1 and the +2, right? That's where it's positive. And so that's where it's above the x-axis. So that's the answer in that case. We're looking for when it's positive. Again, where my function is greater than 0. In the second case here, we're looking when it's negative. Right? Where it's below the x-axis. Well, it's 0 at 1, 2, -1, -2. And so between -2 to infinity, it's negative. Between -1 and 1, it's negative, right? All of these parts, it's negative. And so the other place it's negative is between 2 to infinity. Right? So all of those parts, my function is below the x-axis. So between my zeros and my infinities in this case. So between -1 and +1, it's negative, right? It dips here, it's negative. And then it's negative shooting off to negative infinity, and it's negative shooting off to positive infinity. Alright, so the steps to do this, the process, is going to be the same process that we did before. It's just going to be a little more complex because I've got more zeros and more spots that are above and below the x-axis. So like I said, it's exactly the same process that we used in chapter 3, just a little more complex. So my first example, which I've actually got to mark off my, didn't translate over, this is at 5, and this was at -2, and so here's my function, f of x. Alright, so the first thing we do is we find the boundaries to solve the inequalities. So first thing is, A is asking me for, well, when is the function 0? Alright, well, what are the boundaries? Well, it's 0 when it crosses the x-axis, and it crosses the x-axis at -2 and at +5. It means everywhere else, it's either positive or negative. It's 0 at 2, -2, and it's 0 at 5. And so then I solve for the other inequality. So part B is asking for when is it positive, right? X is greater than 0. We're looking for when it's positive, which means it's above the x-axis. And so, well, what parts are it above? It's above here, right? This piece is above, it's positive. It hits 0. 0 is neither positive nor negative. You don't include the 0. And then it's positive on that piece, going off to infinity. And so it's positive between the -2 and the 5, or from 5 to infinity. Don't include the 5. At 5, it's not positive, it's 0. 0 has neither positive nor negative values. Alright, so that's the answer. My function is positive between the -2, 0 and the +5, 0. It's 0 at 5, and goes positive again after the 5. Alright, the last part is asking for when f of x is less than or equal to 0, and so this time I get to include the 0. So had I been able to include the 0 in the first case, it would go to -2 to infinity. I had it said greater than or equal to 0. It didn't. You don't. This one does. So it's when it's negative to include the 0. And so the place where it's negative is this piece, right? This is the part that's negative, and then I get to include the boundary, the 0. Because I get to include the 0. And then I also have this 0. Alright, so the hard part about this one is the include the 0 part. And so there are 2 zeros that I have to include. And so it's from negative infinity to negative 2, include the 2, so I put brackets, or at the 5, which again, we just put brackets around the 5 because that's a single point. And I get to include the 5 because it's a 0, and that's the part that students will miss. They'll forget that 5 because they'll forget 5 is where it's 0, and I want to include it as well. Let's look at the next example. So this one's a polynomial. It's a little more complex. And so again, I didn't have my 0, so I got to mark those off. Alright, so this one was 10, 4, and negative 8. Alright, for my polynomial. Alright, so the first question, A, is asking when it's 0, right? F of x, when is it 0? Well, it's 0 at the ones I just marked off. Negative 8, 4, and 10. Alright, then B is asking for when is it positive? F of x greater than 0, so it's positive. And so the parts that it's positive is here, right? This piece is positive between the 4 and the 10, not including the 10, that's a 0. And then goes positive again after the 10. Alright, so there's 3 places where it's positive. From negative infinity up to the 0, negative 8. So negative infinity to negative 8, not including the negative 8. Between 4 and 10, not including 10. And then 10 to infinity. Again, we don't include the 10 because we don't include the 0. If we were allowed to include the 0, then we would. We would include the 10, and we'd include the 8, and we'd include the 4. Alright, but that's it. Alright, then the last one's asking you for when is it negative or equal to 0. So again, remember we have the equal to 0 part. So zeros are all included. And so the only place where it's negative is here. Alright, between the 8 and the 4. And then don't forget I get to also include the 10. Alright, I want to know where it's negative. So between negative 8 and 4, include the negative 8 and 4. And then I also include the single point 10. That's the part that's easy to forget, to include the single point 10. Alright, those were polynomial cases, right? This was a polynomial. This was a third degree polynomial. This one looks like it was at the very least 2, 3, 5, 6 degree polynomial at the very least. Alright, next examples are rational cases. So rational cases means I've got to include my asymptotes. Right? So that's the first question. Where are my zeros and where are my asymptotes? So whenever we're dealing with rational cases, I have to ask those because I've got new boundaries. When it's a polynomial, my boundaries are my zeros, and that's it. When it's a rational, I have both my zeros as boundaries, and remember my asymptotes are also boundaries. All right, so that's the first question, and again, I have to label mine because I don't have them labeled on my graph here when I made them bigger. So this was at 5, this was at 2, and I had a 0 here at 6. Alright, so the first question is, what are my asymptotes and what are my zeros? What are my boundaries, right? My asymptotes and my zeros are my boundaries. So my 0, well, the only 0 is 6, right? There's my 0. Then I have 2 asymptotes. I have a vertical asymptote at x equals 5 and a horizontal asymptote at y equals 2. And really, the boundaries are the x values, but it's always good to make note of what my asymptotes are. Alright, I do have a vertical asymptote, not x equals 0, x equals y equals 2. I have a horizontal asymptote. Alright, then my next question B is when is it greater than 0? Alright, when is it positive? Well, this entire piece is positive, right? So it's positive from negative infinity up to my asymptote, my boundary. And so negative infinity to 5, it's positive. And then there's a second place that's positive. This piece is also positive, right? It's positive from 6 shooting off to infinity. So from 6 to infinity. And then negative. So Right, well, actually, there's only one small place where it's less than or equal to 0. That's just this little piece. There's only a little piece there between 5 and 6. That's it. So there's only a small piece. Now, it's going down to infinity, so it's a very long piece. But it's a very small piece. This is the only segment that's negative. And so between 5 and 6, not including the 5, because 5 is an asymptote, it doesn't exist. But I do get to include the 0, right? The 6 is the 0. And so my function is negative or 0 from 5 up to 6, including 6. I include the 6 because it's the 0. I don't include the 5 because it doesn't exist there because it's an asymptote. Alright, the last example of these where we're giving you the graphs. So again, I have to label my stuff. So I've got an asymptote at y equals 0, at 3, and negative 3, and then I've got a 0 at 0. And that's it. Okay, so my first question, which actually is what I just labeled, right? Question A, there's my 0. So A, f of x is equal to 0 at 0, and that's it. That's my only 0. I have vertical asymptotes, 2 of them, at 3 and negative 3, and I have one horizontal at y equals 0. Alright, so there's my asymptotes. Then my less than, greater than's, and equal to's. Alright, f of x is greater than 0, positive. Well, this entire piece is positive, so from negative infinity up to my first asymptote, so negative infinity to negative 3. This piece is positive, so between 0 and my second asymptote, so from 0 to 3. And then that's it. This is negative and that piece is negative. So I'm positive from negative infinity to my asymptote negative 3, and from 0 to positive 3, my positive asymptote. Alright, now the negative part, less than or equal to 0. And equal to 0, make sure it's an equal, yeah, still equal to 0. And so the part where it's negative or equal to 0, well, this piece, right, it's negative, and I get to include my 0. And then this piece, it's negative. Alright, so it's negative from negative 3 to 0. I include the 0. And then from 3 to infinity. And 0 is the only 0, so that's I don't include my asymptotes. It doesn't exist at my asymptotes. Alright, so it exists and negative. From negative 3 to 0, I include the 0 because of the equal to 0 part. And then it's also negative from 3 to infinity, right? That's shooting off to infinity. Alright, so that's inequalities, solving them graphically. We're going to solve them graphically, but the next examples we're actually going to have to set it up. Alright, so there was the graphically solving polynomials and rationals.